So there was a lot going on in that last video. So let's just take a look at the domain and range. So the domain of the combined function formed by the sum or difference of two functions is the domain common to the individual functions. So for example, if I had the domain of f of x is equal to x must be less than or equal to 3, but is a real number, and the domain of h of x is less than negative 5, well, our new domain is going to be the more restrictive one. So less than negative 5 is more restrictive than 3, so therefore that becomes our new domain. Now the range of a combined function has to be determined from its graph. So we can either add or subtract the y-coordinates, or you can just graph the function itself. Okay, for example 2, we're not going to graph these functions. We're just going to determine the equation, so a little simpler again than our previous example. So we have some different functions, f of x, g of x, b of x, and a of x. And we want to determine the equation if we subtract them or possibly add them. So f of x is equal to the square root of x minus 1, and g of x is equal to x minus 2. Now this is subtraction, so I'm going to put a bracket there that will matter. There's nothing I can really do to simplify this square root of x minus 1. Like, without doing some kind of squaring, it's going to stay as a square root. So therefore I'm going to find out, so that's going to stay as x minus 1. We will distribute this, so it becomes negative x plus 2. That's it. Question's done. Nothing else is needed. Okay, a of x minus b of x. Okay, so a of x is x minus 5. And we're going to subtract b of x, which is the absolute value of x. Well, again, there's nothing I can really do with this absolute value. Possibly I could rearrange this, but that's kind of it. And then for our last one, here we have an addition and a subtraction. So we have square root of x minus 1 is f of x plus g of x. Now we don't need brackets because it's an addition. And then minus a, which is our x minus 5. So we do need brackets here. Now there's something I can simplify. So I get plus x minus 2 minus x if I distribute the negative. And so I'm left with x minus 1. And then no x's, and then negative 2 plus 5 is 3. Now the last part of that very first example we did was actually the graphing part. And so I'm going to look at an example that's already been graphed for us. So if we go f of x minus g of x equals h of x. And so therefore I'd get like square root of x minus 1 minus x minus 2 is equal to h of x, which is great. But when I want to actually graph this, I can create the new graph h of x, which is the red graph, by just adding, or in this case, subtracting our height. So if we look right here, we're going to go, it's our blue graph minus our teal. So 0 minus negative 1 is 1. And then again, it's blue graph minus teal. So 1 minus 0 is 1. So going on to where x is 5, we have 3 minus 4 is negative 1. And then this continues on again as 3 minus 8 gets us negative 5. So we can actually build this whole red graph just by subtracting the blue minus the teal, which just represents our two functions. One thing to know though is the domain again is restricted by both of these. So the teal graph has a domain of real numbers, but the blue graph has to be greater than 1. So you see the red graph only starts at that point. Even though there's something that could happen with the teal graph here, there's no blue graph, so therefore we don't even do the red graph or h of x at all. So let's do that ourselves then. So sketch the following graph, state the domain and range of each combined function. So here we have h of x is equal to f plus g of x. So we're basically just going to be adding these two graphs then. So we'll go 1. It doesn't matter with the order if it's red plus blue or blue plus red, it's addition. So we're going to go 1 plus negative 3. Well, that's negative 2. Draw that in green for you. And then 0 plus negative 2 is negative 2. And then here, negative 1 plus negative 1 is 2. And we can already see this pattern is actually going to continue on the whole way. It's just going to be a horizontal line at y equals negative 2. And that's going to be our h of x. Now the reason we end up with a horizontal line is because the blue graph is going up by 1 and the red graph is going down by 1 for its slope. So those slopes are canceling each other out, so you end up with a slope of 0. Now if we want to do our domain of that, well, they both have real numbers to start, the blue and the red, so our green also has real numbers. So we go from negative infinity to infinity. And then for our range actually is quite a bit simpler here. All we have is, it can be one number. It goes from y is equal to -2. That's it. For our second graph, so now we're subtracting f minus g. So that's going to be blue minus the red. So let's start here. So blue minus red. So 2 minus -4. So that's like adding. So we get 6, which is actually already off the graph. Oh, just barely on the graph here. So I won't even continue on that way then. And then 1 minus -3 is 4. And then here 0 minus -2 is 2. And we can see the pattern now. It's going to be linear. It's got a slope of 2. Now because we're subtracting these, our slope ends up being added for them, or in the way that we're adding them, because we're subtracting the negative slope. Now our domain again is going to be the same thing. It's going to be all real numbers because both of the originals had real numbers. And then our range has a little bit more to it. It's any possible number as well. So from negative infinity to infinity, so real numbers. Here, our last one, f plus g. We're going to add them. Now it's a little bit tricky because we've got this point way out here for f of x, but we don't do that anything with any of this graph because g of x doesn't have anything there. So we'll start where they both have a point. Now this looks like it's at what, 3, 4, 5, 6, 7, 8. So that's at 8. So we're going to go 2 plus 8. Well, 2 plus -8 as our height. And so we get -6. So this is just going to go up 2. Now this is a height of 1. So we'll just add 1 to this point. And then as we get here, now at this point they're both going straight. They're both linear. So that's kind of nice. We can just do the endpoints here. So here this is -4 plus -2. So we're going to get all the way down to -6. And then here we're at -7 and we're subtracting 2 more. Now we don't do this part because there's nothing for f of x. And then these should be drawn with a nice straight ruler. We can look at our domain then as well. So our domain is the most restrictive on both sides for h of x. So on this one we have, what is this? 1, 2, 3, 4, 5. So that goes from -5. And it does include that point. And all the way to 3. And again, it does include that as well. And for our range, so this looks like this goes from -9 inclusive. And then this is 1, 2, 3 up. So to -6 also included for our range.